Passive house refers a wide range of technologies, designs, and materials, including concrete and wood structures. Passive, passive house is not a specific house, but a building standard for designing and certifying energy-efficient buildings. It needs only 10% of energy use that a conventional home uses. That's a 90% of energy saving. There are lots of passive house implementation around the world, especially in Europe, but there are few cases in Australia. So the case study of passive house in the environment of Sydney became extremely important. The traditional way of passive houses are adding extra insulation in the wall and creating a sealed layer around the buildings and preventing heat escaping. In this project, based on the conventional criteria, the concept of orientation has been innovatively added. Meanwhile, local prefabricated structures are also chosen to reduce the carbon footprint. This project including 5 aspects. The first point and one of our innovation is to consider the orientation based on the past standard. Good orientation of the house improves comfort and reduces the needs to use energy for heating and cooling. The orientation of the building should be positioned in the path of the sun and prevailing winds. The desired in the amount of solar access varies from season and climate. In Sydney, the sun is located on the north side, so most living areas should face north to allow rooms to receive a long period sunlight in the winter. Suitable eaves should also be designed to protect the rooms from direct sunlight in summer. As shown in figure, the thicker arrows indicate that rooms in this direction receive more sunlight. Other important process aspects based on passive house projects focus on insulation, windows, air tightness, and ventilation. Data collection and analysis are mainly focused on 4 aspects. The first one, energy consumption, will all compared to PHPP forecasts. Ideally, it will be lower. PHPP is the Passive House Planning Package. It's an energy modeling and analysis program for creating a low-energy home. In addition, the temperature data collected during the period will be used to inform the PHPP simulations. Other key effects mainly focus on thermal comfort, indoor CO2 and PM 2.5 concentration. In order to achieve energy saving and emission reduction, this passive house uses technologies such as fresh air systems, prefabricated walls, doors, and rainwater recycling, and more. The first 6 months of the project will focus on construction and inside finish, and the following 6 months will be monitored for data, 12 months in total. That's all my proposal of the project. Thank you.